And we've got Mattia Battiston from giffgaff.
Cool, thank you. All right, start the timer, all good. Now, this talk has got to go well because you need to know I'm Italian, hence the weird accent. It never goes away. I've lived in the UK 10 years, but it never goes away. Especially when I'm nervous, it comes out really strong. I'm Italian, and I thought, well, this coffee is all right, but not great. So just before the talk, I thought, I'll pop down to the coffee shop, get a nice espresso to give me energy. And a seagull decided to poop on me just before this talk. I hope I can say that on camera. I hope it's safe. But in Italy, we think it's good luck. So I got all clean, and hopefully this is all going to go well. My name is Mattia Battiston. I'm originally from Verona in Italy, the city of Romeo and Juliet. It's all about love and hearts and romantic. It's all fake. We build that for tourists, but it's we enjoy that. I'm currently head of software engineering at giffgaff, and I'm here to tell you a story about giffgaff. I'm here to tell you what we do, how we work in technology, and to share this particular takeaway with you that at giffgaff we heavily invest in technical excellence as a business advantage. We are very small compared to our competitors in the market. And despite that, we call ourselves a David amongst Goliath. We are able to really compete with really big companies in a telecoms market that is very difficult to compete in, thanks to the investments we do in technical excellence. I'll tell you our journey of how we got to where we are and the journey we're on, and share these 3 key lessons that we've learned along the way. That we use extreme programming practices to move fast in a safe way. We use microservices and microfrontends to break the dependencies between our teams and scale the organization. And we use team topologies to organize our teams into high-performing teams. And to take you along this journey, I'll use this model that we use internally at giffgaff to represent how technology enables and accelerates the delivery of business value. So we draw it as a pyramid because each layer supports the other. And at the bottom here, we got what we call technical excellence. Those are all our engineering practices, engineering principles, all those habits that allow us to consistently write good quality code that we're always in a position to release. Then we take those habits and we build a tech strategy on top of that that takes those capabilities and points them in a unified way to turn them into a technical advantage, which we use to unlock business value, as I'm going to show you in the rest of the talk. Business value as in ability to iterate quickly, ability to go to market quickly, ability to gain insights, try things, and see what works and what doesn't work with our customers. If you haven't heard about us, giffgaff is a UK-based mobile network provider. We are a virtual network provider. We actually run on the O2 network. And as a matter of fact, we are owned by the Virgin Media O2 group. We are part of their group. We have just over 4 million customers, which we actually refer to as members because we see them as an integral part of our success, as part of our community. And those members tend to love us. Our Net Promoter Score is really high, easily double the average of what our competitors tend to get. So our members tend to like us and stay with us for quite a long time. We are a B Corp certified company, which we are very proud of. And not many people realize that we're actually very small. We have just under 250 people across the whole of giffgaff. About 60% of that is in technology, so we are a very tech-driven company. But as you can see, we're still in that size that is startup, scale-up sort of size, which is interesting to think about if you notice that we have 4 million customers. So we have a considerable chunk of the mobile market in the UK with a very small size compared to our competitors. And that allows us to be very lean, very agile, to react to market and change a lot faster than our competitors can. Our story starts back in 2009, and I call those first few years our birth and growth. We were founded in 2009 as part of O2, and we've always been very community-led. Community was a key part of how we started, so we got a lot of ideas from our members forming their community. We get ideas, feedback. We relied a lot of word of mouth in those early years. And those early years were all about rapid product growth, finding product market fit, finding what worked. And we introduced a lot of innovative things in the mobile market. Things like goodie bags, which is what we call our plans, our packages of minutes and data that you buy from giffgaff. We started selling phones. Fun fact, we were the first company in the UK to push the concept of refurbished phones. Those were the early years of iPhones and expensive smartphones. So we noticed that a lot of people on Google were searching for cheap smartphones, and we noticed that Trend started selling refurbished phones and made them really successful. Best plan advice is something we do every month. We email you, basically telling you, hey, based on your current usage, this is the best plan for you. And we recommend the best plan for you, even if it's a cheaper one, even if it means that you're going to spend less money with us. And that's just an example of how we want to do what's right for our members. And another thing we love is our reserve tank, where if you're running out of data, on most of our plans, we give you an extra gig of data for free, just to keep you going until you're able to buy your next plan. Those are just some examples of why our Net Promoter Score is so high. Our members tend to really like staying with us. We won a lot of awards along the way. So if you walk into our office, you see this big wall of awards that we've won along the years. But like many startups, those years meant that the priority was on finding market fit, rapid growth, expanding our member base. And as such, we accumulated a lot of technical debt. At the time, we started our life with our monolith, because it's 2009, 2010. That's how people used to build software back then. And we accumulated a lot of technical debt to move fast. And I can't blame any of those decisions, to be honest. That's what you do in a startup at the beginning. You need to move fast, try things. You need to write code that you don't know if you're still going to have a month down the line. So we accumulated some technical debt, a lot of technical debt. And it's understandable, but our mistake was waiting too long to realize, because it got to around 2018 when there was a lot of frustration amongst the company. We were getting slower and slower and slower. And in a famous meeting, someone stood up. We were discussing what to do about it. Someone stood up and just exclaimed, you know what, the problem is we can't release. At the time, we were using a very traditional Scrum process, and we were releasing that monolith at the end of every sprint, every 2 weeks. And that meant that we had 25 chances a year to release something and get feedback from members. Only 25 chances. Except that a release back then meant that at the time, what we called our tech ops team used to wake up at 3 a.m. in the morning, physically go in the office. We have our office in Uxbridge. Not sure why it's in Uxbridge. It's a weird area of London, but hey, there you go. Fun fact, Uxbridge is Boris Johnson's constituency. So every now and then you see him walk around, which might or might not be a benefit of being there. Anyway, well, he wasn't around at 3 a.m. for sure. Our tech ops team used to go in the office to do a release in the middle of the night, except more than half of those releases used to fail. We had lots of bugs. Everyone was frustrated. And we estimated that we used to spend around 3,000 engineer days a year just on activities to do with releasing and everything that went around that. So we decided to do something about it. Towards the end of 2018, we did what we now refer to as the big freeze. We stopped for the whole of Q4, the 3 months at the end of 2018. Everyone in tech stopped. And we gave everyone the single goal of automating our deployments. We split into 3 groups. One group was working on creating the pipeline to release that monolith. One group was working on automating how we build servers, and one group was working on creating enough automated tests that we could do an automated release with confidence. And it was a lot of work. That was a really interesting quarter, but we succeeded. This photo is from the early January 2019, when we gathered everyone around the company in the main area of our office. Engineers actually printed a diagram that was showing all the manual steps that they used to do when they were doing a manual release. And as they were talking through what was happening, in the background on the screen, there was an actual automated release going on in the middle of the day, one of the first few releases in the day, going on live. So we succeeded in introducing daily deployments of the monolith, which at the time for giffgaff was mind-blowing. That was a game changer. Now, some of you might think, okay, daily deployments of a monolith, that's cute, but it's not exactly rocket science. Well, it was huge for giffgaff. It was a huge difference from what we were doing before. But if you stick with me for the rest of the story, you will see how that was just the beginning. That was the starting point for us to do a real transformation that led to where we are today. Because around that time, we realized that unless we started to really invest in our technical excellence, we were doomed to repeat our mistakes. And we made the conscious decision to introduce extreme programming practices. And that's what I'm going to do my first deep dive into our engineering principles to show you how we apply those practices. Now, our engineering principles have evolved a bit over the years, but in their current form, they look like this. We have these 5 core principles that are automated testing, pair programming, trunk-based development, keep pipelines green, and continuous improvement. And I'll tell you a bit about each one to show you how we apply them. The first one is automated testing. We ask our engineers to write a lot of automated tests, ideally using test-driven development. And we ask them to make sure that those tests are fast. We want our builds to be really fast so that they can run them all the time to get quick feedback. And the way to keep those tests fast is that we encourage them to refer to the testing pyramid principle. Now, you might have heard about this before. It's been around a while. This is a picture from a famous blog post on Martin Fowler's blog. Forget the names, unit, service, UI. Each team tends to mean different things with those names. But the principle is that you want to have a lot of tests at the bottom that are really fast to execute and cheap to write. So, for example, you can run hundreds and hundreds of unit tests in a matter of seconds. And you want less and less of those tests that are slow and fiddly and flaky to run and tend to be expensive to write and maintain. Things like end-to-end tests or things that have to go through your UI, for example. So our engineers try to follow this principle to make sure that our builds stay fast. We care about automated testing because we want a test suite that we can trust. We want a suite that when it's green, we know it's safe to deploy. You shouldn't need to check extra logs, do extra manual checks, ask for permissions. No, if your test suite is green, you're good to go and you can deploy. And that's the only way for us to reach a high quality that allows us to move fast at a safe speed. Our second principle, and we start to get a bit more controversial here, is about pair programming. We ask our teams that all production code should be written by a pair or more. Sometimes we also do some more programming, but at least a pair. I say controversial because pair programming tends to be quite a polarizing practice. You engineers either love it or hate it. And so we do a lot of work with our engineers to correct misunderstandings, to explain how to do it well, why pair programming is important, the benefits we expect from it. We run workshops with each teams to discuss how to do it. We're a remote-first company, by the way. We do have that office in Uxbridge, but we hire everywhere in the UK. So we operate as a remote-first company. And when we were still in the office, we used to have those pair programming stations with 2 monitors, two keyboards, all set up for pair programming. Since then, switching to remote pair programming has become challenging, I must admit. Doing remote pair programming tends to be more tiring and heavier. It takes a lot more effort. So we train our teams on how to do it well, what tools to use, how to take regular breaks, how to sort out all the various logistics that need to go around making it successful. And we give them this very, very important reminder, because one of the key arguments that we hear against pair programming is, oh, but it makes me slower. I would go faster if I worked on my own, and this is a simple ticket, I can do it on my own. But we remind our engineers that there might be an element of truth in that, but we're optimizing for team performance. So you might individually be under-optimized, let's put it that way, but we're optimizing for team performance. Because pair programming gives us a lot of benefits for the company, for each team, and for individuals. Now, this is a bit of a wall of text. It's an internal slide that we share with teams to explain the various benefits of pair programming. Don't worry about reading them all. I'll just point out the key ones that we stress with our teams. So pair programming has a lot of benefits for individuals, and the most visible one is probably upskilling. If you're a junior working with someone more senior, you learn a lot from that person, but also the other way around. If you're someone experienced working with someone more junior, you learn a lot from having to explain things and to teach others. But what pair programming really shines for us is in the team resilience that it creates. That's the key highlight that we're looking for at giffgaff with pair programming. We use the slightly dark concept of a bus factor, which is the idea of how many people in your team need to get hit by a bus before your team is in trouble. And we're very careful that no one actually gets hit by a bus. But the idea is that if someone has to go off to a meeting, move team, they're off sick, they move for whatever reason, we don't want that to impact the work of the team. There should be a continuous momentum in the team. And that's the resilience we're looking for. No single points of failure, no dependency on any single person, so that work can always continue. And that creates a tremendous amount of side effects that allow our team to be really high performing. Getting even more controversial now, our third engineering principle is trunk-based development. I'll tell you what it's not. Trunk-based development is not feature branching, which is how a lot of teams are used to working. Feature branching would be when you start a piece of work, you create a branch, work on it for anywhere between a few days to a few weeks, God forbid, a few months. Eventually, you would create a pull request, typically, to ask for that code to be merged into the main branch or the master branch. That's not what we want from our teams. We want trunk-based development, where we ask our teams to either push straight to the main branch, or if they're using a branch, to keep that branch very short-lived, where the definition of short-lived is hours rather than days. We want to see a behavior where each engineer in the team is doing multiple small independent releases each day. That's what we want to see in our teams. Every few hours, there should be squash your commits, push, and that gets released to production. And we should see it multiple times a day. Of course, you talk about pushing straight to main, people think, oh, that's reckless. How could you do that in a safe way? We need to make it safe. So we stress to our teams that they need to put in place the practices to make this safe. A lot of automated testing, a lot of pair programming, a lot of feature flags to make sure that the unfinished code we're releasing is hidden, or that feature flag, maybe you enable it just for yourself so that you can do some testing, get some feedback. And we have a lot of observability in place that allows us to monitor if what we've just released is causing any problem, if it needs to be rolled back. PRs are okay. There's nothing inherently wrong with the concept of a pull request. Some teams still like to create PRs as a way to bunch together a bunch of changes and document what those changes are about. But we ask that those PRs are ideally non-blocking. There's this interesting technique that we teach our teams of ship show ask. Well, for each of your change, you reflect on whether, is this something that I can just ship without any review? Is this something that I want to show to the rest of the team? So I create a PR, but it's not blocking. Or is this something that I want to ask the rest of the team for feedback? So I create a PR and wait for it. There's a time and place for all of them, and we ask our teams to reflect on what's best for each change. We love trunk-based development because it encourages those good practices that I was just mentioning. Practices that, as a side effect, lead us to high quality, high speed, high agility. It creates a lot of small changes, and because they're small, they're very safe. And you don't need to believe me, but if you go look the research that Dora did when they wrote the Accelerate book that gave life to the now very famous Dora metrics, in the book they explain how the research showed that there's a very strong correlation between companies that are doing trunk-based development and those companies scoring in the elite categories. Fourth principle, we ask our teams to keep pipelines green. Might sound obvious, but we stress that if your pipeline is red for any reason, your top priority should be on fixing the pipeline, resuming, getting back to a green state so that you can resume continuous deployment, because they should get into a habit of working with a you build it, you own it mentality, where an engineer owns each line of code that they're writing, and they own it from the moment they write it all the way to that line of code reaching production, and they have to ensure that it's performing as they expect it. And the fifth one, again, might sound obvious, but we wanted to remind our engineers to focus on continuous improvement, because we're still on a journey. The monolith that I was talking about still exists in parts. We're still chipping away at that. So we ask our teams to always avoid technical debt if they can, but sometimes we still want to move fast. We might consciously accept a little trade-off just to get to market quickly, so long as we've already got a plan to remove it. So you might do a tactical solution, but we already have in the roadmap a way to redo it. Avoid adding to the monolith if you can, and in general, leave the code in a better state than you found it. Now, introducing these principles and making them successful has not been easy, as you can imagine. We started in 2009 off the back of that big freeze. We brought some experts in at the time to help us with the initial rollout, to teach our teams how to do TDD, how to do pair programming. And we created the first version of this manifesto for Agile product engineering, heavily inspired by the Agile manifesto, where we said things like, we prefer testing first over testing later. We prefer working in pairs over working individually, and so on. And we ran workshops to all teams, and we got engineers to sign up to this manifesto as a way to get them invested into it. And it worked very well at the beginning. For a while, it created a lot of engagement and buy-in. But around 2023, this year, we noticed that adoption had started to suffer. It was a reminder for us that you need to continuously invest in these things. You can't just tell people, go off to TDD and expect them to continue doing it. You need to always remind them why we care about these principles and how to do them well. So in 2023, after a pandemic, after a lot of personnel change, we realized that we needed to revamp these practices, and we revamped our manifesto in reshaping the principles in the form that I was just showing to you. And we introduced a monthly focus on those principles. So every month now we ask each team to reflect on what principle am I going to focus on this month? What experiment am I committing to? We ask them to think of something they want to experiment with regards to one of those principles. We chuck it all in a spreadsheet so that it's visible. It's kind of a visible commitment from the team. They say, this is the area I'm going to work on. This is how I'm going to measure improvements, because we're also quite data-driven. We try to measure the improvements in each principle. And every month, then we gather all teams to have a session to show, okay, this is what happened in my team over the last month. This is what we are doing to improve in these principles, and share a lot of learnings with each other. it's a very, very useful hour that we spend together with all teams to learn from each other. We also get engineers to practice in something that we call a coding dojo. If you haven't heard of the idea, is like a mental gym for engineers where it's a safe space for deliberate practice. We gather for an hour and a half to 2 hours to practice how to implement those principles in a safe way. Usually, the structure of the coding dojo looks something like this. We spend the first 15 minutes, we do a bit of intro, we present the topic of the day. Each time we have a particular topic that we're focusing on. And we present a coding kata, a little simple exercise that we're going to focus on for the day. Then we go off in pairs for about an hour to do the exercise, and we regroup at the end to share learnings. We run this every couple of weeks, more or less, and some of the topics we covered are test-driven development, pair programming, writing good test cases. The Git rows is really fun if you haven't done that. Different pairing tools. This is a safe space for engineers to come practice how to do these things on code that is not production code. They can just create throwaway code and get better at their craft. It's very, very popular, very successful. Our engineers love it. And a key thing we have to get right to keep these principles alive is in making them part of how we hire people. Because as I was saying, some of these practices are very polarizing. Some people will rather not join your company that have to do some pair programming. And that's fine. We want people that that love working with us. We're not going to force anyone to join us and work that way. So we're very clear with candidates in setting expectations from the very beginning that this is how you can expect to work if you join us. You don't need to have done it before, but you need to want to work this way. And we look for those things in our process. So when we do our first CV review, we look for indications that they care about testing, they're a collaborative person. And our first interview step is a live pairing coding exercise where you pair with some of our engineers. And we look for, can you do test-driven development? How do you communicate when you pair? And some coding skills, of course, which works very well for permanent members of staff. We're quite successful in our hiring. Funny enough, where we struggle is with third parties. We use a number of agencies to get extra help while we're still hiring enough permanent engineers. And funny enough, you start a relationship with those agencies and they tell you, yeah, of course we are bought into all these things. We're going to only send you people that are great at TDD and pair programming. And then these contractors arrive and we get by far the most amount of resistance from them. They just don't want to work that way. So just a word of warning, be careful who you work with and make sure that your partners are aligned with your principles. And that gives us the tick, green tick over there. Technical excellence. We now have the foundations of the engineering habits that we need to achieve that technical excellence. Thanks to this lesson, we've learned that we use extreme programming practices to help us move fast in a safe way. But moving fast is not enough. Moving fast on its own is not helpful if you're moving in the wrong direction. And that's where our technical strategy comes into play. That's what we used to point those practices in the most useful direction. So around 2019, after we were done with the big freeze, we introduced our technical strategy, which is made of these 3 pillars. On the left, we've got secure by design, which that's what it says on the tin. We introduced a lot of security practices. We formed a SecOps team. We brought in some experts, and we did a lot of work to shift left on a lot of security practices to keep our services safe and our data safe. In the middle, we got API-centric, which is about creating a set of small independent services that talk to each other using APIs. And on the right, we want to be data-driven, which means having easy access to the data that those services are creating for generating insights and and using data for gaining advantage. I'm going to zoom in the middle on being API-centric, because that's where we started to introduce the concept of microservices at giffgaff. A microservice at giffgaff is a service that a team can independently develop, test, release, and operate. So a team needs to be able to do all those things on their service. And we love the idea of microservices because they help us scale. They help us scale in a number of ways. From an obvious technical perspective, if we have a spike in traffic, it's Black Friday, or we are running a campaign or whatever, it's very easy to just spin up a few extra instances of a bunch of services, and we scale up and we are good to go. That's very easy for us. But where they really helped us is in how we scale the organization, how we scale the number of teams and the number of, the speed that those teams can achieve. A big part of that success has come from the fact that we formed a developer experience team. We formed a dedicated team with a focus on developer experience. Their mission is to make other teams more productive. And the main product they create is a microservice template where any other team, any engineer at giffgaff can, with a few lines of code, with a few commands, they can spin up an empty service that fulfills a whole lot of non-functional requirements, has a lot of sensible defaults, that is basically a service that is almost ready to be deployed to production as is, and you can just focus on your actual business logic that you want to put in it. Engineers can, a team can spin up one of these services in a matter of minutes, and this template comes with a production readiness checklist, which we created in partnership with our SRE team. It's a checklist that gets teams to reflect on all the aspects that they need to care about before something can be safely released to production. Have I got enough test coverage? Have I got automated rollbacks? Have I got enough monitoring? Can I scale up and down if need be? So teams need to think about all these aspects, put a check to show that they thought about it. And that's how we make sure that what we put into production is safe. And thanks to that, we released to production a lot. We have a Kubernetes cluster in AWS where typically we set up a minimum number of instances for each service, and then we tend to scale that on demand as needed. Fun fact, our entire production cluster runs on spot instances. If you're not familiar with AWS, a spot instance is a virtual machine, in quotes, that AWS can kill at any point in time without any notice. That means that our entire, any service is running on an instance that could die at any point in time, which forces us to write services that can die and spin up again without any notice. It saves a lot of money because spot instances are very, very cheap compared to normal instances. And it forces us to write stateless services. So it's a win-win situation for us. And then in the way that we release those services, we are very safe. We do incremental rollouts. So we tend to replace one instance at a time. And then we run some smoke tests on that instance that we've just replaced. We incrementally send more traffic to the instance. And if at any point we notice any anomaly, anything that looks dodgy, we automatically roll back. Thanks to a very advanced observability platform that we've got in place that gives our teams all sorts of tooling they can use to monitor what's happening in production, tracing, metrics, logs, monitoring. We've got full visibility of what's happening in production. And having done all those things over the last few years, this is what technology at giffgaff looks like today. We've got about 140 services, which last year in 2022, we released just over 15,000 times. With a failure rate of 0.35%, code can go to from push to production in less than an hour, typically. We got 3 nines and something of availability, which is plenty for us. We're very happy with it. With a mean time to detect problems of 4 minutes and a mean time to recover from those problems of 40 minutes. Since 2018, we've got we achieved a 95% reduction in P1 incidents. And at any point in time, our services generate 2 million metrics every 30 seconds, which get ingested by our observability platform for all sorts of alerting. And at any point in time, our engineers have access to about 20 terabytes of logs for seeing what's happening. It's a journey. We also still have that monolith behind the scenes that we're chipping away at, but we're quite proud of what we achieved in the last few years. Now, that monolith still has a large part of our front end that used to be written in PHP. Nothing wrong with PHP, but it's quite a few years old, what was written in PHP. So now we are applying the same principles to our front end, and we are introducing the concept of microfrontends, where it's the same concept. It's a front-end service that a team can independently develop, test, release, and operate. Last year, we formed a dedicated front-end developer experience team to really invest into finding the way forward for our front-end. And in all fairness, we're still iterating. We're still finding the right frameworks and ways to do it for us. But the first few experiments, the first few results we got look like this. If you go to giffgaff.com, you see a page like this. And basically, we got different teams that develop different parts of that page. So we got an acquisition team that might focus on the core navigation experience. Right now, we're pushing a lot on the concept of contracts. So our contracts team has got the hero section where they got control of what gets shown here. And a third phones team has got some banners here where they try to upsell some handsets and whatnot. And all these parts can be released and developed independently. All these services that I'm talking about talk to each other using an event-driven architecture. So we ask our engineers that services produce a bunch of events that get consumed by other services, and that's how usually they talk to each other. But most importantly, this large amount of events gets then consumed by, using some clever data engineering, we chuck it all in a huge, enormous data warehouse system with billions and billions of events that allow us to unlock, we'll get a lot of value from all this data that we are collecting. We gather insights, reporting, and use it for machine learning. And some examples are in how we're trying to democratize access to that data. So each team can create dashboards like this. The numbers are pixelated, but you get the gist of it. Teams have got access to dashboards like this where they can see how many members are signing up to my product, where do we see drop-offs, who is leaving giffgaff, all aspects that they can use to make decisions on their products. And we use that data to generate machine learning models. This is a perfect example. We recently created a knowledge bot trained on years and years of responses on our community. And now this bot gives you useful suggestions when you post something on our forums if you're having problems. So we're trying to ride the wave of AI like everyone. And that gives us a tick on tech strategy. Now we've got our foundations of technical excellence. We've got a unified direction thanks to microservices and microfrontends that help us break dependencies and scale the organization. Talking of scaling though, around that time, as the number of services grows, the complexity grows, we start to hit some scaling pains. The cognitive load starts to really grow as the number of services is increasing. We start to lose people. Remember, those were the years of the great resignation and the hottest job market that we've ever seen, with compensations that were crazy, frankly. So we were losing people. It was really hard to replace them. So our teams were getting smaller. At the time, we were still using the concept of the tech lead manager, where the same person in a team was both the technical leader and the manager of the engineers, which is something that works for a bit, but it had reached its limit for us. And the most dangerous one, we were using fluid teams. And when I say fluid teams, I mean, imagine one large team of, say, 30-ish engineers, something like that. Frequently reorganized into sub-teams depending on whatever we were working on during that sprint, and constantly re-teaming on whatever was going on. Now, on paper, that sounds great. That you think, oh, this is extreme agility. We can always repoint our resources onto whatever is our top priority. We don't call them resources, by the way. That was just a joke. And that kind of works in small teams, I find. But as we were scaling up, they started to really break down. Cool, thank you. The cognitive load was too high. Ownership was really unclear. So at the time, we were doing a lot of planning for 2023. And we realized that we had to reorganize. We all bought a bunch of copies of team topologies and used a lot of those principles from team topologies to reorganize our teams. I'm going to skip the theory. You can come and ask me about the theory if you want to know more about it. But the structure of giffgaff, technology at giffgaff looks like this. At the top, we've got a bunch of what we call stream-aligned teams. So, for example, organized in a few different verticals. But in the mobile area, for example, which is what I personally manage, we got a bunch of teams that each own a particular slice of the domain. They own that part of the domain end to end. Our acquisition team, for example, does everything from enticing customers on our webpage to convincing them to buy something and guiding them through the very first purchase journey. We have a complicated subsystem here that we call telecoms. They do the nitty-gritty integration with the network layer, which is really, really complex. If you haven't done that, it's mind-blowing what goes on to integrate with O2's network. It's really complex, requires really deep specialized knowledge, and that's why that's a complicated subsystem. We have a couple of enabling teams whose job is to help stream-aligned values overcome challenges. Those are our developer experience teams. And a bunch of platform teams at the bottom, organized in the data area, platform area, security area. They offer something as a service with the intent of making other teams more productive. We've also introduced a bunch of other improvements, but I'll skip that for now. And that gives us a tick right below business value, because now we've got our teams in the right shape, in the right structure. We are ready to unlock the holy grail of business value, thanks to team topologies that have helped us organize high-performing teams. We get to business value, and the best example I can give you is with something we've launched more or less last month, a brand new product for giffgaff of good contracts. Now, for the first 12-ish years, giffgaff only operated in the pay-as-you-go market, meaning that you buy a plan, you just top up as you need more data, more minutes, or you can leave whatever you want. Extreme flexibility, which is what our members used to love. They still love it, but around the end of last year, we noticed an opportunity to enter the contract market. We made a strategic decision to move in that space. And we went from the CEO having the first conversation with the team about, hey, you know what, I think we should go into contracts. Okay, we'll do it, yes. To the first fully live MVP in about 8 months, which again, some of you might think, well, 8 months, that's cute, but not necessarily groundbreaking. That is a whole new product. Imagine that for 12 years, we only did pay-as-you-go. Introducing the concepts of contracts was almost a complete pivot for giffgaff. So doing that on top of all of the existing legacy monolith and current estate was a massive challenge. And doing that in 8 months is extremely fast compared to the speed our competitors can achieve. And on top of that, now we iterate daily. We gather insights from the data that we get each day. We experiment, do a lot of A/B testing. If you go to giffgaff.com each day, you'll spot something different, basically, and iterate extremely quickly to keep improving on that product. Business value, tick. To conclude and let you get back to more cakes, hopefully, What I shared with you is this key takeaway. We invest heavily in technical excellence as a business advantage. And I shared these 3 key lessons of using extreme programming practices, microservices and microfrontends, and team topologies to achieve the business advantage that allows us to be competitive. I'll share the slides later, but that's all from me. Thank you very much.